Hey, hi friends, welcome back to my channel. So, in today's video, I am going to share some insights about the big data, and moving forward, I will cover some topics on the big data on my channel. So, if you are learning a big data or a big data related concepts, then stay tuned because in coming days, I will be sharing some important concepts of the big data. So, this is the first video and I will start with the introducing what is the big data and what is the big data technology works in real time scenario in today's world. So I will start with one example, and it's very common example. Let's say we have the Netflix. Okay, so the Netflix is the OTT platform, all you know. Thousands of movies, web series are there on Netflix, and on day-to-day life we access the Netflix to watch movies or the web series, correct? So if you think a back-end perspective, like how the Netflix is able to store such a huge amount of video data, right? Because thousands or thousands and thousands of terabyte of data in form of video, and they are able to share that videos on online platform with everyone. Okay, so they are having thousands of TB of data. First thing, and they are storing that data somewhere, and they are using one technology on the top of it, and through this technology they are able to create a platform and share that data with all the end users, correct? So whatever technology they are using is coming under the big data, because in general, in our local system, let's say in our computer, max to max we can store 500 GB of data or 1 TB of data. But when it comes to 1000 TB of data, our local system is not enough capable to store that data, and that is why the big data comes into the picture. So Netflix is one of the example. Similarly, you can consider the Facebook, like in every minute thousands of posts has been created on the Facebook, across the social media, across the groups. We send message to our friends or our network or in our group into the Facebook. So that is kind of text data which is continuously increasing on the Facebook platform, and within a fraction of a second we access that data. So how the Facebook is managing such a huge volume? Because of big data technology. Another example is like YouTube. So on YouTube platform you can see in every minute thousands of video get uploads on YouTube, and on other side in every second thousands, billions, millions of devices are connected to YouTube platform, and they are continuously watching the videos. So how YouTube is able to manage such huge volume of videos? Like when it comes to videos, definitely the data size will be very high, and it is a complicated thing to maintain such huge data and make it available to the end user within fraction of seconds. So how YouTube is managing this? Because of big data technology. So hope you found a very good understanding of what is big data. So still there are some definitions that you can define to understand the big data. Like very first thing is, as per IBM, okay, as per IBM there are four ways to define a big data. A very first V is the volume. Like if the data is very large in volume, like thousands of TB, then it will be a big data. Second definition comes is with veracity. Okay, I'll come to this point. The third one is like velocity, and fourth V is variety. Okay, so we'll come with fourth one, variety. Let's we say the data is thousands of TB, millions of TB, that means very high volume. Variety means what kind of data, whether it's structured data or with is unstructured data. There are two types of data as per the variety, or semi structure you can say. So this is the variety of data, in what format the data is present. Next one is velocity, like what is the intensity or speed of the data. As I said, in every minute thousands of video get uploads on the YouTube. That means thousands of GB data is going to be stored on a YouTube database in every minute. So that is the speed of the data. Now veracity is nothing but quality of data. So in which format the data is present, what is the structure of the data, that is again depends whether it is in textual format or whether it is in comments format, or lots of other things comes here, whether it is in numerical format, again very different thing. So with these four ways you can define the big data concept. Okay, so if you see your data is falling into this category, then you can mark that is as a big data. Hope it is clear to you. Let's move to the next point. Now when I say YouTube, okay, now YouTube having database, let's say YouTube have the database where they are storing all video data, and we as a end user able to access that data within a fraction of a second. That means we are requesting something to YouTube, and YouTube is returning the output to our device. That means it is processing our request somewhere. Okay, so to process this, YouTube need to store this data somewhere first. Very first thing, like to process the data we need to store the data, because without storing the data we cannot process. So storage is the first key, because without storing the data on a particular point or on a particular place we cannot process it. But our system is not capable to process the data, so there is a method that implemented to store the big data. We will come to that point, but that is one of the important key in big data. Second one is like once the storage problem is fixed, now we need to process the data. This is a second challenge or second key. For example, let's say we have the Excel file in our system, and as per the request we have to pull out only some relevant data out of that Excel file. So we can use filter or some mathematical formula or some manipulations within that Excel file to bring out that particular data. But what if the data size itself is very huge? Then there will be a different process, different method to implement. Here the processing part comes in the picture. Third one is like scaling the data. Let's say scaling is nothing but the scale the data quality. Like on YouTube, data is growing very fast, but they are able to scale it in proper format so that we can use few keywords to access a particular video, and we can access to that video within a fraction of a second. So this is possible just because of scaling. Okay, so let's come to the first point, the storage. As we know, our single system is not capable to handle the big data, right? So our single system is nothing but a monolithic. So monolithic system fails to store the big data because incapability, there is no capability. So that's why we come up with another technology called as distributed storage system. So in distributed format, what we do, we use a powerful monolithic system together, and we connect that system to the single point. This could be the another system. So let's say this is 1 2 3 4 5 6 different systems are there which are connected to a centralized system. So this group is called as node. This group is called as cluster, and we have total 6 systems connected together. That's why it is 6 node cluster. So we are using the cluster to store the big data. Now we have, suppose, 1000 of TB of data. So we will divide 1000 GB into 6 system across the 6. So each system will hold equal volume of data as per the data size. Hope this clear to you. So we store the big data in distributed system, which is more scalable. Now we had covered a basic terminology of big data, like basic of big data, how the storage process happen, how we are storing it. We are storing it is in distributed system. Now the next is processing and the scaling. So once we are able to store the data, we can easily process the data and scale the data. Now to process the data and scaling the data, we need a framework, we need a container or protocol, some sort of protocol. And at this point we use Hadoop. So Hadoop works on this distributed storage system to process the data, to scale the data. Hope you got my point. Let me give you another diagram so that it will be easy. So let's say this is our HDFS. Let me define it: distributed file system. H stand for Hadoop. So we have now stored the big data in this particular block. This block refers to cluster. Now we are using a framework called Hadoop to work or to solve big data problem or to process this big data. This will come into the single box. Now Hadoop is framework which is totally managing this volume or this big data. Okay, now let's move a deep inside this Hadoop. So Hadoop is introduced by Google long back on the paper in 2003. In 2003 they released the paper. In 2006 I think they had implemented it, Hadoop, and in 2009 it is owned by Apache, and since 2009 it became open source for all. So that is a basic background of Hadoop, how it came in market. Let it be. So Hadoop is just a front-end framework. It is just a framework to solve big data problem. Okay, so in the single line, Hadoop is nothing but a framework, a container. You can say a framework with certain protocols implemented within it, stage by stage. It follows a path, a flow, and it returns a output depending upon the requirement. So it is just a framework. Okay, now there are two versions as per now. So there are three basically, but in this video I will cover only two, like Hadoop 1.0 and Hadoop 2.0. So in Hadoop 1.0, as we know, we have the HDFS, like the distributed file system stored, and a single block working or processing on the top of the storage, which is Hadoop itself. And at that time it was it is nothing but a MapReduce. Okay, so it is conceptually they gave the name MapReduce. MapReduce is just entity who process the data, big data basically. So in Hadoop 1 only MapReduce was there on the top of the HDFS. Okay, but in Hadoop 2.0 we have the MapReduce and Yarn, which were working on HDFS. So MapReduce is still there, but Yarn has been introduced. So Yarn is nothing but another resource negotiator. Whatever job the MapReduce used to do in Hadoop 1.0, so some of the tasks has been assigned or categorized, and that is dedicatedly given to Yarn to specifically to allocate the resource, so that MapReduce can effectively work on other jobs. So let's say this MapReduce used to do a 10 task, and out of this 10, the 8 was the processing and 2 was the maintain the resources, okay, or allocate the resources. So these two tasks has been shifted to the yarn and 8 to MapReduce. So if MapReduce have the 8 tasks, then that will be completed effectively and 2 will be taken care by yarn. This is just an example to give you good understanding. So MapReduce works more effectively in Hadoop 2.0 because some of the task has been assigned to yarn, and yarn is taking care of memory resourcing of HDFS, and rest of the thing MapReduce is doing effectively. So hope this is clear to you. This is the basic architecture of the Hadoop. Let's move to the next topic, and it is going to be lengthy, but yeah, I will finish this video with this topic, and the topic is Hadoop ecosystem. Hadoop ecosystem. Let's say we have Hadoop 2.0 in system. This is just a framework, but we need other things. For example, let's say we have engine and a body of car, but we need handle, wheel, seats, indicators for the car to drive it properly. Similarly, we need other things, few things to work on Hadoop. Very first one is the scoop. Scoop is used to import and export the data. Import and export the data into the Hadoop. Like Hadoop having the storage system. Let's say we have Oracle system or Snowflake, other data sources. So we want to bring that data to Hadoop, we will use scoop, or we want to transfer the data from Hadoop to this distributed system, we can use scoop. To import the data and to export the data, we use scoop. Okay, next one is Hive. Hive is like the SQL, like to process the data or to manipulate the data. It is just a wrapper on MapReduce, so whatever job we want to write, we can write in Hive. It is kind of SQL. The next one is Pig. Pig is nowadays no one is using. It is used to clean the data, and it is like ETL tool, extract, transform and load. So to clean the data we use Pig, and to perform any ETL operation on unstructured to structured data we use Pig. The next one is HBase. HBase is nothing but NoSQL related database or column related database. So to maintain the NoSQL kind of databases, we are using HBase. Now next one is OZ. OZ is like scheduler or workflow refresher. So let's say we wrote a job in MapReduce to get some update on the data or run the script on particular time. So to repeat that operation we can use scheduler with the help of OZ. It is another big topic, but yeah, it is just a basic intro of OZ. Like if you want to schedule a job or refresh data on a particular interval of time, we use OZ. And the last one is the Apache Spark, and it is the heart of the big data. Spark is like a processor or compute engine of the Hadoop. So without Spark no job can be completed. So let's say we have mobile phone and Spark will be act as a processor of mobile phone. So here Spark is acting as a processor engine or compute engine of the Hadoop. Okay, So in Hadoop cluster we have three important factors. Okay, as I said, this is a basic architecture of the Hadoop, or basic ecosystem of Hadoop. If you want to learn Hadoop, you must know every one of these. You don't need to be expert, but you need to know like each and everything at enough level. So basic architecture of Hadoop is HDFS, then MapReduce, then YARN. Now when the Spark came, HDFS is remains same, MapReduce is replaced with Spark, and YARN is kept as it is. So in the Spark cluster we have this one. So most of the industries are using this infrastructure, and this was the old infrastructure that companies used to do. So this is old, this is new in Hadoop 2.0. Most of the companies prefer Spark to perform all the MapReduce jobs. Okay, so that's it for the day. It was a long video and hope you got some sort of understanding of the big data. In the next video I will try to cover the topic called HDFS architecture, like how the cluster forms, how the block size or block forms in each cluster, how the data gets stored in each block. So that is a very basic of Hadoop. Till then, stay tuned. Hope you like this video. If you like, hit a thumbs up button. You can share your thoughts into the comment section, and till then, take care. Bye bye.